Hi, I'm Joanna S. Lucas from PHY124 and this is for my subject, Physics for Engineers.
Hi, I am Joanna S. Lucas from PHY124. This video is for my subject, Physics for Engineers. In this video, I will discuss how we can solve a problem about projectile motion with general launch angle. So, here is our problem. A projectile is launched from the origin with an initial speed of 20 meters per second at an angle of 35 degrees above the horizontal. Find the x and y position of the projectile at times of 0.5 seconds, 1 seconds, and 1.50 seconds or 1.5 seconds.
Since we are asked what is the x and y by the three given time, which is 0.5 seconds, 1 second, and 1.50 second, and the problem also give us a initial speed and angle. Our initial speed is 20 meter per second and our angle is 35 degrees. With those given, we can use the equation of x for us to find x, which is x is equal to v sub ox multiply to time. And since this v sub ox is equal to initial velocity times cosine theta, we can substitute it for us to use our degree, which is 35 degree. So, our equation for x will be x is equal to initial velocity cosine theta times t. So, here's our equation for us to find our x. So, and for our y, we can use the equation of v sub ox times time minus 1/2 times g times t squared. Since our v sub ox is equal to initial velocity sine theta, we can also replace it for us to use our degree. So, our equation now in y is equal to v sub o sine theta times t minus 1/2 times g times 2 squared. So, here is our equation for our y.
Since we're done knowing our given and our equation, we can now start substituting it for us to solve our problem. First, we will find x and y at 0.5 seconds. So, x and y at 0.5 seconds. So, since we know the equation, we will substitute it now. So, x is equal to velocity or initial velocity, which is 20.0 meter per second, cosine theta, which is our theta is 35 degrees, times our time, which is 0.5 seconds. Since there are both seconds here, we will cancel them. So, x is equal to 20 meters cosine 35 degrees times 0.5 is equal to 8.19 meters. And for our y in 0.5 seconds, we will substitute our given, which is initial velocity, which is 20 meters per second, sine theta, which is 35 degrees, times time, which is 0.5 seconds, minus 1/2, and our gravity, which is 9.81 meter per second squared, times our time, 0.5 second squared. So, since we have seconds here, we will cancel it. So, cancel all seconds since they are equal. So, 20 meters times sine 35 degrees times 0.5 minus 1/2 times 9.81 meters times 0.5 squared is equal to 4.51 meters. So, our x and y at 0.5 seconds is, for our x is 8.19 meters and for our y is 4.51 meters. So, let's erase it and proceed to another time, which is the 1 seconds. So, we will just do what we've done in the first equation or in the first computation. So, x and y at 1 second. So, x, our initial velocity, which is 20 meter per second, times cosine 35 degrees, times our time, which is 1 seconds, and cancel the seconds. So, 20 meters times cosine 35 degrees times 1 is equal to 16.14 meters. So, our x is 16.4 meters in 1 second. So, next, in y, we have initial velocity, which is 20 meter per second, times sine theta, and our theta is 35 degrees, times our time, which is 1 seconds, minus 1/2 times gravity, which is 9.81 meter per second squared, times our time, which is 1 second squared. So, since there is second squared here, we will cancel both of them, and here we have second, we will also cancel this. So, 20 meters times sine 35 degrees times 1 minus 1/2 times 9.81 meters times 1 is equal to 0.57 meters. So, our x and y at 1 seconds, our x is 16.4 meters and our y is 0.57 meters. So, last time is 1.5 or 1.50 seconds. So, let's erase it again. So, x and y at 1.50 seconds. So, let's substitute it. For x, we have initial velocity, which is 20 meter per second, cosine theta, our theta is 35 degrees, times time, which is 1.50 seconds. So, let's cancel the second, and 20 meters and times cosine 35 degrees times 1.50 is equal to 24.6 meters. So, our x is 24.6 meters. And lastly, our y at 1.50 seconds, y is equal to initial velocity, which is 20 meter per second, times sine theta, which is 35 degrees, times time, which is 1.50 seconds, minus 1/2 times gravity, 9.81 meter per second squared, times our time, which is 1.50 seconds squared. So, let's cancel again the seconds here and here. So, 20 meters times sine 35 degrees times 1.50 minus 1/2 times 9.81 meters times 1.50 squared is equal to 6.17 meters. So, our x and y at 1.50 seconds is, in x, it is 24.6 meters and for y, it is 6.17 meters.
For us to see all the x and y that we've got using all the three time, I will write it again. So, x and y at 0.5 seconds, we got for x is 8.19 meters and for y, we got 4.51 meters. And at x and y at 1 seconds, we got for x is 16.4 meters, and for y, we got 0.57 meters. Lastly, for time, 1.50 seconds. So, x and y at 1.50 seconds, we got for x is 24.6 meters. And for y, we got 6.17 meters. So, this is our x and y that we got using the time 0.5 seconds, 1 seconds, and 1.50 seconds. So, that is how we can solve the problem in projectile motion that has angle and it is looking for its x and y. That's all. Thank you for watching.